Okay, hi folks. This is the first assignment, and it corresponds to the one given in the lab in the morning. There are two problems to be looked at. One of them is the following situation: when you have a shaft like that clamped at one end, and pressure is applied to the face A, B, C, D. The dimensions, of course, are given here, and I'm going to make that for you in a second. But notice that this is like any problem on the test is going to say, make sure that first of all, use all planes of symmetry, if any, okay? All planes of symmetry, if any. Now, in this particular problem, because of the nature of the geometry, the loading, and the restraint, there are two planes of symmetry. You can cut it with the XZ plane, and you can cut it with the XY plane, okay? Uh, the two planes of symmetry. And if this problem was given on a test, you would have to use both of them, okay? Now, it says that use the most appropriate element in this particular problem. And at this point in the course, the only element that we know how to use are these tetrahedral elements, which are look like pyramids, linear or parabolic. And in the absence of any instruction, you can use the type of element that you want. It doesn't say use linear or parabolic, etc. And finally, it says that make sure that in this problem, you have a finer mesh around the fillet. Okay, it doesn't say how much, but we want to make sure that you know how to create or refine a mesh in a certain area. So my first attempt is going to be make this geometry, cut it, save it with the appropriate name, run the analysis, save it with the appropriate name, and once I'm done with that, then I go back to my the cut that I made and uh, see if it applies to the next problem or not. Let's not worry about the next problem right now. I'll just move on and make this thing. Okay, so default material properties from steel. So we're not going to change any of the values that are given. Okay, so let's go ahead here. And we start with the part file. I advise you to start with part file now that we're not dealing with assemblies yet. Okay. Immediately, I'm going to save that. Or actually, well, let's wait until later on and save it later on. Okay. So on this vertical plane, I will sketch a circle of radius 0.5. That's the radius of the shaft, like this. And let's dimension it. These dimensions are in inches, so 0.5 inch. Okay, good. So now we exit and we shaft it or pad it, not shaft it, pad it by, it says 10-inch long. Okay. And we are given some graphical instructions here on how to make this little, let's call it handle, this little handle. So the dimension of that little handle is 0.315 and 1.5. Okay, so we go on that face, sketch. Let's fit this thing so that it comes back. Okay. Let me draw a centered rectangle, like so, and dimension it the way it's given. So this one is 1.5. Okay, and that is 0.315. 0.315. Very good. Exit. Okay, let's fit this thing right there. There's the sketch. We can see that. We will pad this in the instructions. The instructions says that this thickness is 0.5 inch. So let's do that. 0.5. Okay. And we're also given some fillets here. So let's go ahead and randomly make some fillet. I don't think that the details of that fillet were given. Uh, Ordinarily, we will tell you what the fillet radius is. I don't see. Oh, here, zero point 0.1 inch. 0.1 inch the radius of the fillet. Okay, so we can do what we can do is we can do a 3D fillets. So right there, see that edge fillet. This put down 0.1, and then simultaneously I can do it at the other side, but let me do it separately. Okay, on that side. Okay, same value. So there's my geometry. Let's make this thing out of steel. You were told that this is a steel part. Yeah, steel part. See that? The part shown below is made of steel. So let's go ahead and apply material to it. Apply material. Is this little box with something being dropped into it? I don't know why they chose that particular icon. So under metal, you scroll down, select steel on the part, and we're going to say OK. Very good. And this problem has two planes of symmetry, so I'm going to cut it. Let me put this thing in. Yeah, let's cut it. Here's the split. Katia calls it split, doesn't call it cut. Let's cut it with the vertical plane, and it doesn't matter which side we pick. And then let's cut it again with the horizontal plane. We'll keep the top part. Okay. So this is 1/4 of that model, and I'm going to save this thing. File, save management, save as, desktop, new folder, and I'm call it uh, assignment 1. Problem 1. How about that? Problem 1. If you want, I will call it 2 planes of symmetry. Leave 2 planes of symmetry here also. 2 planes of symmetry. 2 planes of symmetry. How about that? Of symmetry. Let me copy this. Oh, wait a minute. Actually, I did it. I'm going to do it differently. So let's call it assignment 1. Assignment 1, okay? But in this folder, I'm going to put both problems, okay? So the name of it, though, the name, there's the name. I'm going to paste whatever I did. So here's the way it goes. I created a folder called assignment 1. In this folder, I'm saving the part that I have exactly as you see, and I called it assignment 1, problem 1, 2 planes of symmetry. Okay, very good. That's better. So it goes into that assignment 1. Okay, very good. So now we're going to go to generative structure analysis, analysis and simulation, generative structure analysis. Katia will mesh this thing, automatically put a mesh there, and we're not going to change that. You're not asked to do it. It may be horrible mesh, and it is a horrible mesh because the size of it is too big for that end, for that handle. Let me change the rendering here to uh, the not the one with the material shading. It's called shading with edges without smooth edges, etc. Anyway, so here is my mesh. Let me just make sure that it is at least parabolic. Yes, yeah. And now I want to do local mesh refinement in this area. So you go to this toolbar where you have the traffic light and everything, expand this menu, and over here it says local mesh site. You click on it, and okay, you zoom in, you select that face. Notice that here it uses a mesh size that's well smaller than that. And you can change this thing if you want. You can make it. You can make it bigger. We can make it smaller. That's really not the point. Now we know that if you're asked to do this thing on the test, at least you know how local mesh size works. So mesh visualization, just to convince you that actually we have a finer mesh there. It's right there. Okay. The very fact that this mesh, these elements are big, it's a terrible mesh. And then we make it actually see the faces are not even following the cylindrical border. So I'm going to make this thing smaller, just so that it looks a little bit nicer. Maybe 0.3. The other one, the local mesh refinement, I'm going to leave it the same. So you see, instead of that big size, at least it's a bit more respectable. So we go and activate this again. See, it's more respectable. Even if it's bothering you more, you can do that smaller, but that's okay. We don't need it. Finer meshing around the hole, etc. So deactivate the mesh, because with the mesh sitting in front of you, staring at you staring at it, there's nothing else you can do. So the surface slider is going to go on places where we made the cuts. So at the bottom and on the side, we can do that separately, or we can do it in the same. You know what? Actually, let me do the following. Let me do it separately, okay? So here, surface slider here, and do another one. You could have done it at the same time. Okay, good. That back end is clamped. And we're told that a pressure of 400 psi is applied to that end face. Remember, pressure is per unit area, so you don't have to take 400 divided by 4. If it was 400 pounds, then on this face you would apply only 1/4 of that. But pressure you don't do that. Okay, so this is compressive, so it's going to be 400 psi. Okay, you'll notice that the direction changed. Very good. So before I do the problem, let me go ahead and save this thing. So it's going to be File, Save Management. Here's my analysis, Save As. It's in the same folder, assignment 1, except that at the end, I'm going to do a paste so that whatever I did before is going to appear. Assignment 1, problem 1, 2 planes of symmetry, okay? And we say okay, and okay. This is pretty much it. So let's go ahead and run it, make sure it works, and we are not in this assignment and in this course in general, we don't debating the accuracy and things like that. This message you always get, or already told you that. So let's change the rendering here. It's a very tiny amount. You can see that that's nothing. This is the one. This is a displacement, very tiny, and you can see why, because a gigantic piece of a thick piece of steel. You're applying 400 psi on it. 400 psi is not much load. That's why there's very little displacement. Will be very little stress on it also. There we are. In the event that you want to see the mesh on this also, so you can go here at the very bottom. There's where the rendering is at the very bottom. There's a question mark. There's one of these suddenly with a question mark. You click on it, and then yeah, you see that there is edges and points, etc. So good. So this problem is done, and we save. We save. Now I want to close this. I want to close this. I have two choices. I can close this, or I can keep it open, but later on when I save it with the appropriate name. So this is done. You do it the way you feel comfortable with. Let me go back to that part. My part is still back there. What was the problem that we were doing? The second problem that we're doing is the same geometry, so I don't have to create it except for removing the splits if needed. The loading is different. Instead of applying a pressure here, I'm applying a torque. So actually it's under couple, force, 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 force. Okay, I think the magnitude of those forces are given 100 pounds on each edge. Okay, 100 pounds on each edge. 100 pounds this way, 100 pounds that way. This obviously has no planes of symmetry. So what I'm going to do is I'll go to the part. Oh, where's my part? Right there. Okay. Where's the part? Oh, there's the part. Okay. These cuts, I'm going to splits, I'm going to remove. So delete and delete. There we are. Now I'm going to save this thing. File, save management. This is the modified part right there. Save as. See, this is the part that's open. I made a change here. Save as. I'll put it in the same folder, but the name I'm going to say no planes of symmetry. Because I changed the name, it did not overwrite the old one. And save. Okay. All right. In fact, if you go to that folder that I created on my desktop, which was called morning, right? Assignment 1, not more. Assignment 1. You see that I have the two parts. One of them is called two planes of symmetry, the one that we already finished. The one that I made no planes of symmetry, I removed the cut. This is the old analysis, so that's fine. So let's go ahead and uh, I can close this. There's no need to keep it open, but if you want, you can keep it open too. The analysis here. See, already the stuff is gone. The geometry is the correct geometry because I removed the cut. But these old sliders are from before. Okay. So two things. First of all, I can save this thing, file, save management. In that folder, this is the analysis. In that folder, oh, I should have called it save as. Oh God. Okay. Save as, no planes of symmetry. I have bad news for you. I messed up the very first one because I said save. I didn't say save as because I was planning to change the name. Bad idea. Okay. I should not have said save. I should have said save as. Change the name. But anyway, so I lost basically my first problem. Yeah, you can see that. We'll see what happens. Okay, you see what happens in that folder. Which one was it? In that folder, my parts are okay, no problem. But this, it says two planes of symmetry. Okay, so I really screwed it up here. This is why it would have been better if I created two folders. Problem 1, problem 2. And if yeah, so my apologies. But that's okay. Let's go ahead and do the rest of the problem. Assignment, analysis right there. You can see how, just to save some time, completely putting these in different places really shot myself in the foot because I lost the first analysis. Okay. All right, let's go ahead and, oh, these sliders were put on surfaces that do not exist anymore. Let's go ahead and delete them. So on the restraint, these surface sliders do not delete anymore, do not exist anymore. So delete it. And I suspect that that message that I got was telling me this. I didn't read it carefully, but it was saying, hey, you put stuff on surfaces that do not exist. So let's go ahead and do that. We don't have any surface slider anymore, but we do have a clamp. This clamp at the right side. Okay, very good. And the pressure, the pressure is okay, although there may be some, let's see now, although there is this because the surface has changed, but that's okay. The surface has no problem with it. It'll adjust by itself. Here, I select this. There. That error message that I got was the fact that, hey, you remove the surfaces, but the surface sliders are already there. And that's mainly because yeah. Let's go ahead and run it. Oh, whoa, no pressure. Oh, this is the second problem, right? Sorry, there's no pressure there. Whoa, delete. No pressure. The second problem was a different load. It was under a torque. So let's go and apply a distributed load on this edge in the direction. The way I've done it right now, it's going to be, if you want to make it look just like that, it's going to be direction Y. Okay, so 100 in the direction Y, or negative. Okay, although it really doesn't matter for the present problem because you're doing the same deformation, but I'll put exactly like the loading is in this side diagram. And on the other side, all I do is to put a minus, remove the minus. Yeah, there. So this causes a torque. Let's go ahead and run it. This will twist as it's supposed to. That's why there are no planes of symmetry here. Very good. Let's look at the deformation. There we are. And you can animate it if you want. Now, yeah, that's pretty much it. You can see that this is the stress, very small stresses. These are not much. And deformation is displacement. If you want to plot it like that, you can see that the arrows make this thing twist. There we are. So that takes care of the homework problem for the first section, which was lab one. In lab one, but I really screwed up when I did the saving. If you close that, let's check it out. If you close first of all, let's save this thing. Save this. Okay, so I'm going to close that. I'm going to close this. Let's go ahead and see what we got in that folder. That folder was here, assignment 1. Notice that I lost the first one. The part is still there. With two planes of symmetry, the part is still there. But the analysis is gone because I overwrote that with one which says no plane. Remember, this was two planes of symmetry. It's still there. And of course, the next one that I did is also still there with no planes of symmetry. No planes of symmetry. This is the part, okay? But when you go to the analysis, I overwrite. See that? My first one. Let me open this. Yep, that's gone. Terrible. All right, don't make mistakes like this on the test, please. Bye.